All right, guys, so let's get into the next section here. This one's about inscribed angles. But first, let's do a little warm-up reviewing our last section, which dealt more with central angles and arc lengths. So if you want to take a minute, just kind of think about what the measure of arc LN would be, the measure of mark PLN, and then the value of X. So go ahead and pause the video and see if we can get those set up as a little review. Okay, so let's take a look. The arc from LN here, if we just measure again from L to N, the arc again is the curved segment of a circle, and we're measuring it in degrees. We're not really measuring its length. We could, it's just a portion of the circumference, but the actual measure of it is an angle, or a degree measure, I should say. So in this case, it's just the 40 plus the 38, so that measure of that arc would be 78 degrees. Okay, PLN, so if we go from P all the way through to L to N, so all the way there, we can see it's the 142 plus the 30 plus the 78, which I believe adds up to 220 degrees. And then finally, the value of X. Okay, so we see there's a 5X here, so this arc is 5X. So if we think about the green arc from P to L to N was 220, this remaining blue piece is the rest of the circle, so the rest of the 360. So that must be 140 degrees. But again, that is 5x, right, based on the central angle they gave us there. So if we just take the 140 and divide by 5, we should be able to get our answer that x would end up equaling 28. Okay, and that was just using the theorem from last section again, that the measure of the arc is equal to the measure of the central angle. Okay, and again, the central angle means that its vertex is in the center of the circle. Okay, we will see something slightly different here coming up right now. All right, so the that section that we just finished and the warm-up, that was 10.2 in the book, that was all about central angles again, where the vertex of the angle is the center of the circle. Now an inscribed angle, okay, this is what the new section is going to be about, 10.3. If the vertex of the angle, see, it's not at the center of the circle there, the vertex is actually on the circle, and it forms an angle here, okay, and there's an arc formed still, right, so there's still some arc formed from there to there, but the issue is, what is the measure of that arc? Is it equal to the measure of the inscribed angle, okay, like if this is the angle theta here, would the arc be the same? And the answer is actually no. Okay, there's a theorem here. There's definitely a relationship, but it is not equal to the angle, as was the case with central angles. Okay, and here's the theorem, and we'll do a few examples using it. The measure of the intercepted arc equals twice the measure of the inscribed angle. Okay, so if we take a look at this picture here, here is an inscribed angle. Again, because the vertex is not the center of the circle, right? The vertex is a different point on the circle. So it does still form an arc, right? There's still arc AB from here to here. Okay, and the theorem simply states that the intercepted arc is twice the measure of the angle. So if that angle is 25 degrees, and that's an inscribed angle, that means that the arc AB, the measure of it would be twice. It would be a 50-degree arc. Okay, is always twice the measure of the inscribed angle. So let's use that. Let's see if we can do a couple examples here. Here's like a little figure here. We got a circle, we got a bunch of arcs. They want us to find ABE, ACE, and ADE. And if you take a look, they are giving us an arc from A to E. That's the only given information. That arc's measure is 90 degrees. Okay, so if we take a look, starting with the first one, starting with ABE, notice ABE, okay, is an inscribed angle, right, because the vertex is on the circle, and it created an arc of 90 degrees, and the previous theorem said that the arc, so that means if the arc is 45, that means our angle ABE, would be half of that, would be 45 degrees. All right, we see if this angle right here is 45 degrees, it would form an arc twice as big. Okay, it would form an arc of 90 degrees. Okay, and if you take a look at all three of these, look at the next one, angle ACE, right? It forms the same arc, right? Its endpoints of the arc are still A and E. So angle ACE is also 45 degrees. Okay, and then finally, the yellow one here, A to D to E. Okay, again, same thing. It's forming the same arc. It's an inscribed angle, so its measure is also 45 degrees. Okay, so each of these angles are congruent. They all form to the same arc, and it was just a matter of knowing that the arc measure was twice the angle measure. Okay, and one more example. Let's see if we can get this one figured out. So we have this angle measure, RQS. We can see that angle is given as measured 4x plus 8, that angle there. The arc now is 10x. Okay, and we want to find the measure of the arc. Okay, so what kind of relationship do we know? Okay, again, it's an inscribed angle, right? I would go back to, is the vertex of the angle is on the circle. Okay, it's not a central angle. We're not using that point right there. Would be the center of the circle. Okay, our vertex of our angle is not there. Okay, so what we do know though is that the arc, the 10x, must equal twice the angle. Right? So 10x, the arc, just to kind of explain this, arc equals twice the inscribed angle, right? So we can write ourselves a little equation. We can hopefully do some algebra here, figure out what x is, and then we'll be able to solve for what we need. So in this case, the algebra 10x, we'll distribute this 2 over here as one option, 8x plus 16. Okay, if we minus 8x from both sides, we will get 2x equals 16. Okay, and dividing by 2, of course, x equals 8. Now our question was not just to solve for x, we needed to know what's the measure of the arc RS. Well, RS is 10x. Okay, so arc equals 10 times the x value, so it must be 80 degrees. Okay, and just for completion here, not that it asked, but the angle should be then 40 degrees. Okay, if we needed that, that would be 40 degrees. And you could check that by plugging in the x we got. Also in right there, 4 times 4, 4 times 8, 32 plus 8 is 40. Okay, but again, we just needed the arc length, the arc measure, I should say, and in this case, 80 degrees. And that is that. So just one last time, just to make sure we're visualizing everything clearly. The difference again is the previous section. Okay, you would have a central angle, and in that case, the arc equals the measure of the angle. So the measure of the arc equals the measure of the angle. But the new case, so what you're going to be looking for is that the angle, instead of being at the center of the circle, will be on the circle. And if that's x degrees, and the arc measures over here, and in this case, the arc equals 2 times the angle measure. Okay, so just kind of keep that in mind. That's the difference. That's what you're looking for visually, and that will help you get these problems set up. All right.